Hello everyone and welcome back to another video. Hope you're doing well. In today's video, I want to show a project that is still in the works. It is essentially a Pac-Man clone. Let me go ahead and fire this up here with npm start. All right, it just opened it on another monitor, but before I show it, I want to talk a little bit about it. So again, this is a work in progress. I use JavaScript, CSS, HTML, but I want to talk about Phaser.js a little bit, a deep dive into modern web game development. So Phaser.js represents one of the most sophisticated and well-architected HTML5 game frameworks available today. At its core, Phaser is built around a robust entity component system architecture that leverages WebGL through Pixie.js for hardware accelerated rendering, while gracefully degrading to Canvas 2D when WebGL isn't available. It's pretty cool. What makes Phaser compelling from a technical standpoint is its approach to the game loop and scene management. The, the framework implements a highly optimized delta time-based game loop. It ensures consistent performance across different devices and frame rates. Now, this is crucial because unlike native game engines that can rely on consistent hardware, Web web games, must adapt to everything from high-end desktop machines to mobile devices with varying computational capabilities, right? Excuse me. The scene system in Phaser is built around a sophisticated lifecycle management system. So each scene goes through distinct phases: init, preload, create, and update, with additional hooks for pause, resume, and destruction. This architecture decision allows for incredible flexibility in memory management and state transitions, which is essential when dealing with JavaScript's garbage collection patterns. One of Phaser's most impressive features is its physics integration. The framework ships with multiple physics engines: arcade physics for simple AABB collision detection, and matter.js for more complex rigid body dynamics. The arcade physics system is well designed for games like Pac-Man because it provides pixel perfect collision detection with minimal computational overhead. The collision system uses spatial partitioning through a quad tree structure, which reduces collision checks from, I don't remember 100% exactly. I can kind of see it in my head. The input management system deserves special attention as well. So Phaser abstracts away the complexities of handling different input methods: touch, mouse, keyboard, and gamepad, through a unified event system. So this is important for cross-platform deployment, as the same codebase can seamlessly handle desktop keyboard controls and mobile touch gestures. From a rendering perspective, Phaser's use of object pooling and batch rendering significantly reduces garbage collection pressure. When sprites are destroyed, they are not immediately deleted, but rather returned to a pool for reuse. I was just talking to somebody about this the other day. We were in a discussion about GTA 5. Anyways, that's interesting. I just know. So, so what am I saying? Where was I? I lost my train of thought. Um, so, so the pattern is crucial for maintaining consistent frame rates, especially in games with many dynamic objects like particle systems or enemy spawning, for example. So now I want to dive into something a bit different here. I was thinking about implementing a Pac-Man clone using Rust compiled to WebAssembly or WASM. Is that right? This approach represents the intersection of systems programming performance with web platform accessibility, and it opens up fascinating possibilities for video game development. WebAssembly is a low-level assembly like language that serves as a compilation target for languages like Rust, C++, and Go. What makes this interesting for game development is that WASM or WebAssembly provides near native performance inside the browser while maintaining the security sandbox that makes web applications safe. Oh, by the way, what you're about to see, I know I'm blabbing, but I've been thinking about this all day. What you are about to see is not 100% complete, as it is a work in progress. I've got a lot of work to do to it, but I love Phaser, I love Pac-Man, and I'm just having a good time with this. So let's see. What else do I want to talk about here? What else do I want to talk about? When we compile Rust to WebAssembly for game development, we are essentially creating a hybrid architecture, right? So the the Rust code handles the computation handles, what am I trying to say here? It handles the computational, I can't talk. It's it's intensive game logic, pathfinding for, say, ghost AI, collision detection, score calculation, and game state management. While JavaScript manages DOM interaction, audio playback, and canvas rendering coordination, the Ghost AI in Pac-Man is an excellent case study for this architecture. Each ghost has distinct behavioral patterns, right? Blinky pursues Pac-Man directly, say, uh, Pinky attempts to ambush by targeting four tiles ahead of Pac-Man's current direction. Inky, is that right? Inky? Inky uses a complex targeting system based on, say, both Blinky's position and Pac-Man's location, and so on and so forth. So, implementing this in Rust allows us to leverage the language's zero-cost abstractions. I know for a fact I've talked about this before in the past, and fearless concurrency. I feel like how many times have I said concurrency on this channel? So we can represent the game state using Rust's ownership system, uh, which eliminates entire classes of bugs common in, say, C++ game development, in particular around memory safety and data races. So the pathfinding algorithm deserves special attention. While A is the gold standard for pathfinding, Pac-Man's grid-based movement actually benefits from a modified breadth first scratch algorithm in Rust. We can implement this using how do you say, what am I saying? VecDec for the queue, and leverage the type system to ensure our grid coordinates coordinates, excuse me, are always valid. So the borrow checker prevents common pathfinding bugs like accessing invalid grid positions or creating cycles in the search. Memory management, talk a little bit about this, and then I'll go ahead and show this project. Memory management in WASM or WebAssembly presents unique challenges and opportunities. Uh, WASM has a linear memory model, essentially a large array of bytes that both the WASM module and JavaScript can access. So Rust's ownership system maps beautifully onto this model because it provides compile time guarantees about memory safety without requiring garbage collection. I don't know. Hearing myself talk, I think I may have to I prefer Rust over any other language, but I think what I want to do, let me refresh this. I think what I want to do is attempt to make a Pac-Man clone using Rust and WASM. You know, I think I think one of the most compelling aspects of of that approach is the ability to share game logic between platforms. The same Rust code base that compiles to WASM for the web can also compile to native binaries for desktop platforms or even to mobile platforms using frameworks like Bevy or MacroQuad. Now, Bevy I've struggled with a bit in the past, I'll be honest, but MacroQuad has been great so far. Hopefully in the future I'll be able to get some things done with Bevy. Is there anything else I can think of? I could talk about debugging. I don't want to. Error handling. I don't really want to talk about that right now. So this is it. So there's a lot going on here that needs to be fixed. Let's go ahead and get into it. So here it is, and I made this playable for both a left-hand person and a right-hand person. If you're left-handed, you would use AWSD keys to control the yellow circle, if you will, and then arrow keys for right-handed. So you can see one of the issues. My ghosts are all present, but they are all in the exact same location. And it takes a moment before they start venturing out. So I need to separate all the ghosts and have them come after me, as to be expected in a Pac-Man or Pac-Man clone game. Let me just keep going here a little bit. Power pellet. There you go. I need to fix that too. The ghost, or I should say the ghost turned blue. It's flashing. And my pellet counter needs to be fixed. And I also need to go back to the level design in the code and stretch it out a bit, and look at that. I'm sad because I had this working and I did something. I broke it. And then the other thing I wanted to show too is when you finish a level, it actually just repeats. Do I want to go through it all? I'm just going to go ahead. I've made it this far. I want to show you what it's doing here. The movement is not too bad. I need to avoid that ghost, or I should say that cluster of ghosts. I know they're all there. They're just moving all at the same time. Try and stay away from them here. Okay, almost done. All right, so if I hit spacebar, see, that's another one of the issues I need to fix. And then also, where's my cursor? You see down here? I had this filled in, but then I had the idea of writing some verbiage down here, and I ended up with this. So what I'm thinking I'm going to do is get rid of the verbiage down here, fill it in, and then I wanted to have some animation in the background. Originally, I had some like late 80s, early 90s graphics going on in the background that were just slowly spinning in a circular motion. I scratched that, and then I came up with a still image. I scratched that, and then I came up with this. To be honest with you, I don't really like this either. So I'm going to change that as well. And I'm also going to make the play area much, much bigger. I'm going to go ahead and get hit by a ghost really quick. And this is another thing I need to fix. All right. It got me. That's good. Problem is, though, is if I collect a power pellet, watch what happens. You see? So it needs some work. It needs some work. It needs work. Excuse me. Let me close this out. Close this. Quite a bit of code going on here. I'm excited about doing more projects in the future with Phaser. I'm still learning a lot. I've got a lot of notes on it, and there's a whole lot I don't quite yet have a grasp on just yet. But that is yet another video. I hope you enjoyed it. I appreciate you stopping by. It went on a little bit longer than I wanted to, but I really wanted to talk about Phaser.js, and I wanted to talk a little bit about creating a Pac-Man clone game using WebAssembly and Rust, which again, the more I hear myself talk about it, the more and more I want to do it. Well, anyways, that's another one. Thank you very much for stopping by, and I will see you in the next one.